Boeing 787 system oversight error number 2, the main battery relay. This is not about the battery diode module. This particular part is about the main battery relay and its logic and commands from the bus power control unit. This is a lot of information to give you. I'm going to start off with looking at a diagram. We have the main battery diode module, hot battery bus, main battery relay to captain's instrument bus across to first officer instrument bus. Okay. Excuse me. Outwards from the instrument bus, the captain's instrument bus, should be the battery charger through the back of the diode module to join into the pre-diode before it leaves the battery to charge the battery. Okay, the battery charger is monitored by the bus power control unit's left. If something goes wrong with the battery inside, a fault can be detected by the battery charger and sends that information to left bus power control unit. Now, if something's wrong with the battery, you want to know about it pretty quickly, but some little things can go wrong which could be ignored. So therefore, I'm sort of skipping across to the point here, which is that this system waits 15 seconds for a main battery fault to continue before it does anything about it. So once the battery charger has sent that fault signal to the left bus power control unit, okay, provided that the captain's instrument bus is still up, and this condition happens for 15 seconds, okay, meaning the bus power control unit is still live because the captain's instrument bus is still able to power it. Provided that happens for 15 seconds, it will disconnect the main battery relay. That alone tells you the main battery relay was connected, right? Closed means passing power, open means open and not passing power. They're not connected. So it doesn't mean open means it lets electricity through. Closed lets electricity through. And a short circuit, if there is one. Okay. The reset threshold is irrelevant. Okay. So what are we looking at here? This is the main battery relay. Here, green, connected. And you'll notice in the comments at the bottom here, MBR is controlled from the flight deck only. We can't turn it on and off from the breaker control system. It can't be done. Only the button above. Okay, so yes, the relay is controlled by the bus power control unit, but it doesn't just leave it off. Now, I have videos in flight of the main battery showing discharge during flight, periods of discharge, proving that the main battery is indeed closed during flight. The main battery relay is indeed closed during flight. This aircraft is slightly different to anything else in history. Historically, aircraft would leave this relay open and connect it when needed. But this is a flying DC UPS with wings. Okay? And that is why they needed this. A big, fat diode module. And that is so that this can remain closed and the isolation is taken care of via a solid state device called a diode. The diode makes sure that electricity can only flow out of the battery so that current doesn't flow into it other than from the charger. And that's the charger cable there, that little one. So one of these is battery positive in and the other is battery positive out. And that battery positive in is also a way for the charger to get back into the battery. All right, and that's how it's monitoring the condition of the battery and sending that information to the bus power control unit. The system oversight error here is the 15-second countdown. If this happens on takeoff, that is very bad. What they didn't know that 15-second countdown could be during a fault, and that fault could be doing something else. That lack of battery power might do something they hadn't thought about yet. And I tell you, I know what that is. And that's the reason that 260 people died. That's for a different video. I am segregating the information into absorbable little chunks of information that the mums and dads, anyone, with all due respect, something that you can analyze and understand. Okay. Now, just going to some published data. The main battery, here we go. The main battery is connected to the hot battery bus through the battery diode module. That's it there. Okay? The battery switch here. These are the main indications on the battery switch. On means the main battery relay is closed and battery power is connected to the captain and first officer instrument bus. So here we go, during flight, zoom in, that's on. Okay, it's a very grainy picture, but I can tell you that the top means on. Look, on. Off is at the bottom, on is at the top. Okay, so during flight, this was on and the main battery relay was connected and closed. Off would mean the main battery relay is open. Now, there are times when the main battery relay does open, and that is particularly during charging. There are these charging cycles, and Boeing designed it so that during charging, the main battery relay would open, and that doesn't happen during takeoff. Okay? So unfortunately, in this case, the battery relay was closed and needed a 15-second countdown. This is an oversight error. They didn't know what could possibly go wrong if the battery failed. They didn't learn from the Takamatsu event. They just simply didn't know when they designed it, and nothing improved. Okay, so what did they do after the Takamatsu event? They grounded the fleet and put something in called a stainless steel box. This thing here. That's the box. Inadvertently, what they did here is they put 60 bolts around the battery, which made it very, very difficult for the maintenance engineers to inspect the condition visually of the battery. And you will see from YouTuber Stig Aviation, he even complains about it in his tour of the electrical bay. He mentions that it's a pain in the ass, he says, to get to the battery. So therefore, it's very difficult to look at the battery. So if it is swelling, out of shape, or something's going wrong, you won't see it because it's inside that box. All right, and you have to undo 60 bolts. It takes him half an hour just to get into the damn thing. So what did they do? They made that box. They put some extra spaces inside the cells, yes, but they did this. They put the box in, which limits the dangerous fire and smoke, vents gases overboard, and protects the airplane structure. It makes no mention of fixing the electrical fault, whatever caused this to happen, and it makes no mention of assessing, in all of their reports, no mention of assessing the risk of what might happen if the battery does this. What is the risk to the electrical system, or what might cause a problem? Okay, there's a battery switch on the P5 electrical panel, as I showed you. When this switch is on with the airplane on the ground and no other external power sources available, the BPCU would close the main battery relay. Okay, the main battery now supplies, because of that relay and the diode allowing power to flow, the main battery now supplies the captain's instrument and first officer's instrument bus. Yes, there's a test switch, which they should be using. No idea if they did. But truth be told, the battery probably measured completely fine. Completely fine, because this was a thermal runaway event, which happens in a matter of seconds. Alright, so that's the basics of the battery from that document. Now let's go to the Boeing training document. Student notes from Boeing. Zoom in even more. Zoom in even more. The main battery supplies standby power for the following: flight critical components and loads until the ram air turbine extends. That includes the instrument buses. It also includes the flight control electronics, which are the things which power the aileron, rudder, and all that. So the main battery is there before the flight control electronics resort to their own internal batteries. It goes main aircraft power. If main aircraft power is lost, it goes to main battery. If main battery is lost, the flight control electronics continue on their own internal batteries. All right. Another one, electric brakes when all other 28-volt DC sources are not available. Okay, keep that one. The reason is the electronic brakes take 28 volts DC and step them up to 130 volts DC through a isolated DC-DC, I guess you call it a DC-DC transformer. It's a power supply that steps up the voltage from the 28-volt bus, so that if the aircraft isn't running, the brakes can still work from the battery. To keep it simple, they just made it so that the system can be fed by the battery or the main 28-volt buses. Two inputs. Keep that in mind. The battery is also for when they're refueling the left main tank. It also powers the bus itself, which is the hot battery bus, which also powers the instrument bus. Kind of a pointless line there. Towing and ground operations initial power, and that ground operations initial power means exactly what I said before. Turning on the aircraft, you push the button, the power comes from the battery. That's all it's saying. Okay. Further down, this is the next extract from the same page of that document. The main battery provides emergency power if all alternating current is lost. Okay, batteries are direct current, DC. So what they're saying here is that it provides emergency power if the source of that DC, the rectifiers, if they lose their alternating current input, and that's the engines spooling down. Okay, so when the engine's spooled down, the battery would take care of the required DC power until either the engines come back or the rat deploys. It has sufficient capacity to supply power to all the standby loads during emergency aircraft operations until the rat generator is deployed. The main battery can also provide braking power after landing. That's interesting. After landing. Okay. It helps the DC 28 volt system. The brakes use a lot of power. A lot. 100 amp breakers are installed for the brakes. 4 of them. Okay, for the rear. You've got left side has 2 and right side has 2. Okay, the main battery is always connected to the main hot battery bus through the battery diode module and through the main battery relay. Now that's a little bit incorrect because the main battery relay is after the hot battery bus. Okay, so it goes battery, diode, hot battery bus, main battery relay, first instrument bus. It will supply power to the captain or first officer instrument bus for one of these conditions. Here we go. On the ground with the battery switch in the on position and no other source of power available. So what that means is if there is external power, or if the engines are running, there'll be generators. If the engines are running or there is external power, the diode doesn't need to do anything. It doesn't do anything. There is no current flowing out of the battery because the power already exists on the DC circuits supplied by the alternating current fed rectifiers. What that means is if there is no power on that bus, the battery, through that one-way solid-state valve, the diode, supplies the power required. It's a no-break DC UPS. Power can come from alternating current source or from direct current source, storage. Okay, another one, it will supply power to the first officer instrument bus for the other condition, refueling. All right. Or in the air and a loss of power to the captain's instrument bus. Now, I tell you now, they didn't think they were designing this for a time where it would take a while for the battery to turn on. No, this is no break. Okay, the captain needs his instruments, and it takes care of that until the ram air turbine deploys. Look, I just wanted to point out in this video, the 15 seconds, that is your system's oversight error. 15 seconds could spell life or death if you haven't thought about the issue of a main battery fault. And that's for another video.